Hi students, let's look at this question here, which was taken from the year 2019, paper 1, question 10. So you are given this parametric equation here, which is actually like x equals to a 2 cos theta minus cos 2 theta, and y is equals to a 2 sine theta minus sine 2 theta. Alright. The first thing to take note is essentially try and just sketch this curve here, but I know there's both positive and negative side here, but use your GC, just bring out a GC and just try and sketch and see how this curve is going to look like. Now, but just take note, sometimes students forget to change the boundary. So for 0 between theta to 2 pi, just remember to change the boundary there. So from here, I've already sketched it. So for your A, you could put a positive value or negative value. You could just try and see, but so after keying in, we could actually just put this as like a positive. A is positive, or you could just put a negative. So for the window settings, just make sure it's 0 to 2 pi here. I'll just put a positive value. It looks like that, right? The thing is, if this is a negative value, it's going to look something like that. Okay, so it really depends on which one do you take. So we just take the positive one, but specify it. Specify it in the question that you're taking the positive part. Okay, so it looks something like that. So I'm going to zoom in. This is a graph that we see. That's pretty okay. Try and see. Actually, they don't ask for the x-intercept or whatnot, so we're just going to copy and paste this graph here and see what we get. Okay, so this part here, for the first part, the graph that we get for a bigger than 0, okay, we get the graph this shape here. But if you take the negative one, it will be the other shape. Okay, so I'm just gonna use my Desmos to sketch. So as you can see here, with a different value of a, the graph that we're looking at is different. So this is you can actually easily key this easily into Desmos to be able to see how this graph will look like. So I'm just gonna roughly take the positive one, but if you take the negative one, it's fine also. So yeah. So from this part here, you're just told to subsequently you're just told to actually just find the what do you call it, the line of symmetry. So meaning to say you don't need to prove that there's line of symmetry or whatnot. You just see as it is. Some students will say that, Mr. Khan, I can't see the line of symmetry because maybe the settings of calculators, for example, zoom standard, you may not be able to see that this is like. So you could actually put zoom square. Just remember, zoom square is to make the ratio of the x and y axis the same. So it looks something like that. Okay. So once this is done, we are going to just key in as this is y and this is x and this is 0. That's all. So from graph, the line of symmetry is just the x-axis, so y equals to 0. Alright, that's how you do this question here for the first part. So let's look at the subsequent question. The subsequent question, you're told to actually find the value of theta at where c meets the x-axis. Meeting the x-axis meaning is here. This part here, this is x-axis, so this is when y equals to 0 and this is y equals to 0 as well. So we need to find these 2 points here. Finding the theta, so meaning for part 2, when c meets x-axis, we have got y equals to 0, meaning to say y equal 0 equals to y, the equation of y, which is this one here over here. This one over here, so this is 0 equals to a 2 sine theta minus sine 2 theta. Now, the first thing you should be able to take note is that the angle are different. So what you need to do is this one change to the same angle as the first one, meaning we use the double angle formula. Sine theta cosine theta 0 and cosine theta 1 minus cosine theta. Okay, now you realize that A-level have been like trying to test quite a bit of O-level additional mathematics stuff. This is one of which. So 2 sine theta, just do this properly. This one will be 2 sine theta equals to 0, or 1 minus cosine theta equals to 0. So sine theta equals to 0, or cosine theta equals to 1. Okay, sine theta equals to 0 will be theta is actually equals to 0. could be pi or 2 pi. Okay, cosine theta equals to 1 will be 0 or 2 pi. That's all. So basically theta is 0, 2 pi. Now check your calculator. So if you check your calculator, just press 0 here, it will be here. There's 1. After which you press 2 pi and just trace and see. Sometimes overflow is because the window settings, the 2 pi, they couldn't put to the same meaning to say that this is like overflowing. They can't really put exactly 2 pi. So you can just, this is 2 pi, 6.28 is 2 pi, but we can put 6.3 here. Then you just trace again and just put 2 pi so that your calculator can, put in 2 pi, the value in, and you realize it's here. And trace again and put pi. These are all exam techniques. I hope you understand. So this is this is the x value, don't care because it may not be correct. So this is it. So this case here would be theta is equal to 0, pi, and 2 pi. Okay, these are all the values of theta which will give you this point here. So this would be corresponding to t equals to pi. It's good to just put theta equals to pi over here. This is when theta equals to 0 or 2 pi. Okay. Yeah, okay. Okay, let's look at the subsequent part here, which we are told to actually find the area here, the bounded area here, and asked to be expressed in the form. Let me just write it down in this form here. So this area in this form here, we need to show that the area enclosed for the above is actually from theta 1 to theta 2 and a square, 4 sine square theta minus 6 sine theta, sine 2 theta plus 2 sine square theta. Okay, so I'm just going to write this down here. Plus 2 sine square 2 theta. Okay, great. Before we start, I think what we should do is just find the boundary here in terms of a. So for this case here, when theta is equal to pi, we know x is equals to a, 2 cos pi. Pi is 180 cosine 2 pi. Pi 180 would render it to be minus 1. Then 2 pi will just be, so this would just be a. 2 times negative 1, so it's negative 2 minus 1. Okay, so this is negative 3a. So this point here actually is important. This point here, which corresponds to pi, is actually negative 3a. Maybe I just put negative 3a like that. Okay, so this is okay. Then after which this part here is actually theta. Okay, just remember that that's a corresponding point. After which you have got theta equals to 0. So x is equals to a, 2 cosine 0 minus cosine 0 here. Cosine 0 is 1. So this will just render as a. Okay, so check your calculator here. This is a. So this one has got, okay, it has 2 values here, but we will talk about that later. So this is 0 or 2 pi. Okay. Now, usually what I tell my students to do is actually to take note of how the pi changes, because you know that pi starts from 0 here and it just increased to pi on the other side here. So in order for you to visualize it properly, what you need to do is actually, if you look at the p here, you start off with 0 here, and because your p parameter is from 0 to 2 pi, it will go one full circle. So here's about 2 pi, right? So the question now is, how do you actually find the area enclosed above circle? One thing that students will typically take note is because there's this bump here, which is quite annoying, right? Okay, this bump here, which is very, very annoying. I understand, but let me tell you that actually the parametric equation would actually what do you call it? It will actually settle it itself. Okay, so this point here, if you want to find out, what we do is essentially by writing in the Cartesian form. Okay, so I'm just gonna let this point here be parallel to the y-axis. I'm gonna show you how this is being done. So let point K be point on C such that tangent is parallel to y-axis. I actually don't really need to know. I just need to show you that actually it will be a continuous curve, and theta equals to theta, and theta equals to theta k. Okay, just as it's theta k. I don't care. I just basically want to show that this is k, and let's say this is xk and this is yk. Actually, you don't really need the yk, but okay, I'll just let it be like that. This point here. Now, if you want to find the area under the graph, area enclosed. Okay, so students will say, how come? So what we need to do is actually from minus 3a to k, meaning we get the area under this graph, right? Including this side here, right? So this part here is important. So I'm actually taking, maybe I should just draw out the area. I'm taking this area here. Okay, then this is the area here, minus off the bottom small area here, the small bump there. So that small bump there would just be this small bump here. Okay, what you eventually get is actually this bump here. So the area enclosed will just be from integral of negative 3a. This is what you do, right? You start with 3a here to end with xk, right? So I'm just going to end with xk, which corresponds to theta k. So this is y dx, that's okay. Then after which I will just start with the bottom one will be a to x. So this is a to xk over there. So this is xk. Okay, this is xk, okay? Is y dx over here. Great. So once this is done, what we're going to do next is actually just try and just minus 3a xk here, y dx. So we know that if this minus absorb plus xka y dx, okay? And this could actually combine because minus 3a to xka, you can actually combine them. And in secondary school, we get it. Actually, we don't really need a k there. We will just settle everything by itself, which is the amazing thing. Minus 3a to a. Yeah. So, yeah. That's how you do it. Then what you do is actually you just change it to the parametric form, right? So parametric form would mean that we would make y just sub y and so on, and just try and find. So this part here, parametric form, remember this point here, a corresponds to theta. It should be from theta because you're starting from here to here, okay? So it should from theta equals to 0. Then this part here, because we are looking, remember this is 0 to 2 pi, okay? So your starting point is important. A is actually theta equals to 0. This corresponding parameter is theta equals to pi. Remember that. So y would be, I'm just going to copy the values down. So this part here would just be pi, and this is 0. And y would be a 2 sine theta minus sine 2 theta. Then you need dx. Dx, we're just going to differentiate x here. So dx dt, d theta will be a negative 2 sine theta plus 2 sine 2 theta. Yeah, and after which we're just going to bring that down. Let me just copy it down. Dx a minus 2 sine theta plus 2 sine 2 theta. Sine theta plus 2 sine 2 theta, and this is d theta. Okay, great. So minus sine theta plus 2 sine 2 theta d theta. Yeah, there you go. So once done, I'm just gonna group the a together, and this is pi. 0, this is a square. This is minus 4 sine square theta plus 4 sine theta sine 2 theta. Minus plus 2 sine theta. Just expand it, and this will just be minus 2 sine square 2 theta d theta. Okay? So once this is done, we are more or less there, because now take note of what they ask you to show. They want it to be in a positive form here. So what we're going to do is actually just extract the negative out and flip the sign top and bottom, right? So this is pi 0 a square. This is for a lot of things, right? A lot of things. So sine. Then this is plus. Minus, sorry. This is minus. 2 sine square theta. 2 theta d theta. Yeah, and I'm just going to flip it up and down. Pi 0 a squared. This is how you do this question here proficiently. If you have questions or comments, please let us know. I do know that this question here is a bit difficult if you are considering the harm there. But just take note that actually the parametric equation, if you integrate from here to here, it will just find the enclosed area. Okay, so that's one way to know. But if you are not too sure, you could actually work it out like that. Yeah. So once you do the third part, I think for the fourth part should be quite okay, because you're told to find in terms of the exact total area enclosed by C. And since the first part you're told that the line of symmetry is actually the x-axis, what you could actually do is just use whatever you found in part 3 and just multiply it with 2, right? So I think that is pretty okay. Let me just go through this properly. So enclosed area would just be twice of what we found in the first part, which is this one, right? Twice of it, because of the line of symmetry there. So that's pretty okay. I think once this is done, we just put a squared, and then it will be 4 sine square theta minus 6 sine theta. Now this sine 2 theta, they're multiple to each other, so I'm just going to use a double angle there, 2 sine theta cosine theta plus 2 sine square theta 2 theta d theta. Now once you see this double angle here, please make sure to know that you are supposed to use, this square here, we need to use a double angle formula, which is cosine square A is equals to 1 minus 2 sine square the A, right? So in this case here, I have 2 sine, basically sine square A. Sine square A is equals to 1 minus cosine square A. Cosine 2A. What am I doing? Oh my goodness. A over 2. Yeah, right. So this is, once this is done, we are going to just replace all of this in. This one over here, we could actually, I think, use the cancelling method. So, or the f prime fx method, whichever method you are taught. Okay, so this is a recognizable form. Yeah. So sine square theta cosine theta plus 2 sine square. So this is 1 minus cosine 4 theta over 2 d theta. Okay, so this part I think should be quite okay. I'm just going to bring this to the other side, and this will cancel away. So this will left 2 minus 2 cosine theta. So we'll cancel this away, right? So multiplying. So that's pretty okay. So multiply 2 in, we get 2 cosine 2 theta plus 1 minus cosine 4 theta and d theta. I could just split this to minus 12 0 to pi sine square theta cosine theta d theta. Okay, so this part, the one behind is just a recognizable form. I think that 2 plus 1 is 3, so I'm just gonna express this 3 theta minus sine 2 theta, integrating this divide, right? Minus sine 4 theta over 4. This will be pi equals to 0. This will be 12. And this will be sine theta cubed over 3. Okay, there you go. So this one's done. We could actually use 0 to pi. Yeah. So this could be cancelled away as well. And this will just be 4. And I'm going to replace the value in. So this is 2 square. This is 3 pi. Sine 2 pi is 0. Sine 4 pi is 0 as well. 0, everything is 0. So I'm quite happy with this outcome here. This over here will be 4. Sine pi will be 0 as well. So 0, 0. Yeah. So what is left is actually just 3 pi to a square times 3 pi. Okay. Now, please don't take the answer as face value. So I would always encourage students to just key in calculator and check. Okay, so what I'm saying is you just key calculator for this expression here, the one behind it, and always check in the exam whether your answer is correct. But I've already keyed in just now, so I'll just show you how we key. Just key this in, press enter, this value turns out, and you just divide it with pi, and you will know that actually your answer is correct. Okay, so this is how you do this question here proficiently. Please know that these are all important exam techniques that which will help you, all right, in exam. Yeah, keep practicing, and I'll see any question, just let us know, and I'll see you in the next question. Okay.